Hello dear friends, welcome to Karna Academy. Today in this video we are going to discuss one of the most important question which is frequently asked in SE examination class 10. We are going to solve question number 24B, which is from page number 226, Math Links book, class 10. The question is, in the given figure, PQ is the diameter of the circle. In the given figure, PQ is the diameter of the circle with center at O. If Px is equal to Xs, if Px is equal to Xx, prove that Ox is parallel to Xq. Prove that Ox is parallel to Xq. Dear students, in this question, the question is PQ is diameter of the circle with center at O. If Px is equal to Xx, then we have to prove that Ox is parallel to Qs. So the question is very simple. In order to prove this theorem, our theorem of circle, at first we have to take construction. We'll join OS, then we'll show two triangles congruent, and after that we'll use the property of inscribed angle and central angle of circle. So let's write one given at first. A circle with center O. A circle with center O. A circle with center O. PQ is the diameter. PQ is the diameter. PQ is the diameter. Px is equal to Xs. Px is given equal to Xx. To prove Ox is parallel to Qs. Ox parallel to Qs. Dear students, we need a small construction. So let's write down construction at first. Construction, join construction is, we have to join OS. Join OS. So we have to take a very simple construction, join OS. Dear students, after joining OS, O to S, we have got two triangles. First triangle is OPX and second triangle is OSX. So after showing two triangles congruent, we'll get angle POX equal to SOX. Then after that, we'll show the relation between central angle and inscribed angle of a circle standing on the same arc. So after showing angle POS equals to angle OQS, we'll get OX parallel to SQ, because when the corresponding angles are equal, then the two lines are parallel. So let's prove the two triangles OPX and OSX congruent. Proof. Dear students, in the exam we should make table in which we have to write serial number, statements, serial number and reasons. So first let's write down serial number. Then we should take statements, then again serial number and reasons. In statement number 1, let us take triangle OPX. In triangle OPX and triangle OSX. In state number 1I, this means in order to show two triangles OPX and OSX congruent, the two triangles must satisfy the facts of any one of the 5 facts of congruency test of two triangles. So dear students, we know that altogether there are 5 facts of congruency test of two triangles: ASA, SAS, RHS, SSS, and AS. This means we can easily remember the 5 facts of congruency tests of congruent triangles by Nepali rhymes. आशा eating sauce, RHS, SSS, आश गर्नु तर भर्न पर्नु. आशा, that means angle side angle. Eating sauce, that means side angle side. RHS, that means right angle hypotenuse side. SSS, side. And आश गर्नु तर भर्न पर्नु, that means angle side. So if two triangles satisfy any one of the 5 facts of congruency test of triangles, then the two triangles will be congruent. This means in this case two triangles OPX and OSX we can show congruent by SSS fact. We are already given PX is equal to XS. OX we can take as common side, and we can take OP is equal to OQ, because OP and OQ, we can take OP is equal to OS, radii of the same circle. So by SS fact we can show two triangles congruent. So let's write down at first PX is equal to XX. So let's write down at first PX is equal to XX. The reason is given. Then we can take OX is equal to OX. We can take OX is equal to OX. It is common side of two triangles, common sides. And number three in statement number 1 triple I, we can take OP is equal to OS. OP is equal to OS, radii of the same circle. RADII, radii of the same circle. Radii of the same circle. Now in statement number 2, now we can write triangle OPX. Triangle OPX congruent to triangle OSX. The reason is by SSS, side fact, SSS fact of congruency test of two triangles. Dear students, we know that when two triangles are congruent, then we can write corresponding angles of congruent triangles equal. Angle POX is the side opposite of the side. Dear students, after showing two triangles congruent, we can take corresponding angles of congruent triangles equal. Angle POX is the side opposite of PX. Angle SOX is the angle opposite to the side PX. Angle SOX is the angle opposite to the side XX. So angles opposite to equal sides are called corresponding angles. So dear students, we can take angle POX equals to angle SOX, corresponding angles of congruent triangles. So let's write down angle POX. POX is equal to SOX. Angle POX is equal to angle SOX. The reason is corresponding angles of congruent triangles. Angles of congruent, this is the symbol of congruent, corresponding angles of congruent triangles. Dear students, let's look at the figure. Angle POX and angle SOX. So after adding angle POX and angle SOX, we get angle at the center, which is obtained by the arc PS. So let's write down angle POX plus angle SOX equals to angle POS. So let's add two angles. Let's suppose this angle as A. Angle POX plus angle SOX equals to angle POS. So supposing this angle as A and this angle as A. So after adding angle POX and SOX, we'll get angle POS. By whole part exam, we get angle POS. Angle POS. So dear students, angle POX and SOX. Angle POX and SOX we have supposed equal to A. So we can write A plus A is equal to angle POS. Therefore, angle POS is equal to 2A. Dear students, angle POX, we have got A plus A equals to A, which is obtained by the arc PS. And again we have got angle PQS, which is also obtained by the same arc PS. So if angle at the center is 2A, then angle at the circumference will be just half of the angle at the center. That means if angle POX is 2A, then angle PQS will be equals to A. We know that angle at the center is twice of angle at the circumference, or we can say angle at the circumference is half of the angle at the center of a circle standing on the same arc. Or simply we can say inscribed angle. Inscribed angle is half of the central angle standing on the same arc. So we can relate the angle at the center POS with the angle at the circumference PQS. So let's write down angle PQS is equal to half of angle POS. We can write angle PQS. We can write angle in statement number 5. We can write angle PQS. Angle PQS, half of angle POS. PQS is equal to half of angle PQS is equal to half of angle POS. That means 1/2 of 2A. So 2 we can cancel, equals to A. So this is the reason is the reason of statement 4 is whole part exam. By adding parts of angle we get whole angle. So this is whole part exam. The reason is by whole part exam. And in statement number 5 we can write relation between central angle and inscribed angle. It's between central angle and inscribed angle standing on the same arc. Inscribed angle standing on the inscribed angle on same arc, obtained by the same arc, ARC arc. Test now in statement number 6 since angle S since angle POX is equal to A, and again angle PQS is equal to A. So let's look at the diagram. We have got angle POX equals to A, and angle PQS also equals to A. So these two angles we have got equal. That means these two angles are the corresponding angles which is made by the transversal PQ with the two lines PX and SQ. So dear students, when the corresponding angles are equal, then the two lines are parallel. So just now we have shown that angle POX equals to angle PQS. That means angle A is equal to angle A. Corresponding angles we have shown equal. So we can say that PX is parallel to SQ. So by combining the two statements, angle POX equals to A, and PQS is also equals to A. So let's combine the two statement. Angle POX is equal to angle PQS, and we have supposed equal to A. So number 7 we can write combining statement 3 and 5. So dear students, now in statement number 7 we can say that OX is parallel to, now we can say that OX is parallel to QS because we have shown corresponding angle equal. So now we can say OX parallel to QS, which is the proof of our theorem of circle. So let's write down PX parallel to QS. Let's write down OX parallel to QX. Now we can easily write OX parallel to QS. So dear students, so we have got OX parallel to QX, which is the proof of this question number 24. So number 7, this is statement number 6. In number 7, this is from statement 6, being corresponding angles equal. So dear students, before we end this video, let's discuss once more. The question is very simple, and this question is frequently asked in essay examination also. So dear students, in question number 24, which is from our page number 226, Maths Links book 10. So in the question is, in the given figure, PQ is the diameter of the circle with center O. PQ is the diameter of the circle with center at O. If PX is equal to XS, prove that OX is parallel to QS. So dear students, to prove this our theorem of circle, we have to take a small construction, join OS. This is O, join OS. So after joining OS, we have got two triangles, OPX and OSQ. We have got two triangles, OPX and OSX. So by showing two triangles congruent by SSS fact, we can take this PX is equal to XX, we can take OX is equal to OX as common side, and we can take OP is equal to OS, radii of the same circle. So by SSS fact, we can easily show the two triangles congruent. Then after showing two triangles congruent, we can take angle POX equal to SOX, and both angles we have supposed as angle A, corresponding angles of congruent angles. Dear students, by adding the two corresponding angles, A plus A, we get 2A, which is angle POS, which is the central angle POS. So now we'll show the relation between angle at the center and angle at the circumference. Dear students, we know that inscribed angle, or we can say angle at the circumference, is always half of the angle at the center subtended by the same arc, or we can say standing on the same arc. So if angle at the center is a plus a to a, then angle at the circumference will be just half. That means we get this angle as a. That means angle POX is equal to angle PQS. Both angles we get equal to a, because half of 2a we get equals to a. That means we get angle POX equal to angle PQS, which are corresponding angles made by the transversal PQ, or we can say made by the diameter PQ with the two lines PX and QX. So when corresponding angles made by a line with two lines are equal, then the two lines are parallel. So in this way we can easily prove that OX is parallel to QX. So thank you dear students for watching this video, and next time again we'll meet with new video. Till then, bye, have a nice day. Thank you.